Okay, today's lab is about regenerative braking, which we find on all of our electric vehicles and all of our hybrid vehicles, with the exception of some very, very early ones. To understand regenerative braking, we have to understand basic braking. When you think about basic braking, what we're doing is we're transferring energy. We got the kinetic energy of the car rolling down the road. We need to stop the car. We have to take that energy away. We can't get rid of energy. We can only change it into other types of energy. So what we do with our normal standard braking is we change that kinetic energy of the car rolling down the road into heat energy. We do this by applying the brakes. When those brake pads hit the rotor, they generate heat. That's heat energy. What they're doing is they're taking the kinetic energy, the motion of the vehicle, they're changing that kinetic energy into heat energy. So the kinetic energy goes down, the heat energy goes up, we dissipate the heat off into the atmosphere, and that's how we stop the car. So we're changing that energy from one form to another. That's base braking. With regenerative braking, what we're doing is we're changing that kinetic energy, that motion of the vehicle, into electric energy. So we're going to take and we're going to turn that into an electrical force, the voltage, which then generates the amperage, and we're going to use that electricity, that electrical energy, to recharge the batteries. So we can keep a charge on the batteries. This will maintain a charge, kind of like an alternator is not designed to charge a dead battery. It's designed to help maintain the battery's state of charge. So we're going to do that through electrical energy. Now again, using that alternator example, how does an alternator work? We change that kinetic energy of the rotation of the engine into electrical energy through magnetism, right? Everything comes back to magnetism. So we take that spinning alternator, that rotating motion of the alternator, and we induce voltage into the stator windings, and we use that voltage to run our vehicles, maintain our battery charge. We're going to do basically the same thing. We've got these motors that are driving the wheels of the car. When we want to stop the car, we'll take the energy of the wheels moving, put that into the motor, and let the windings in the motor generate electricity. When it generates electricity, it puts a drag on those wheels. We're changing that energy. We're taking the energy away from the motion of the wheels, and we're putting it into generating that electricity. You probably have heard me say before, if you ever tried to take an energized alternator and turn it by hand, you can't do it. You got to be a pretty big, strong person to grab a hold of that alternator when it's energized and turn it. It takes a lot of force. We see the same thing. Now think about the motors in our electric vehicles and our hybrids and compare them to an alternator. An alternator is relatively small. The motors in our cars are huge, so they've got a lot of force in there. If we have to fight against that force with the rotation of the wheels, it's going to slow the vehicle down. So what I've got with this lab sheet, I have a demonstrator that I put together that gives us an idea of what's going on. I use a DC motor. It's actually just a fan motor out of an air conditioning system, and I'm going to spin that motor, and then I'm going to use the electrical force to slow the motor down. So the lab sheet goes through a number of steps. It goes through checking the amperage being developed, the amperage and voltage being developed when there's no load on the motor, when there's a light load, and when there's a heavy load. So we're going to go through and we're going to do that step by step. So I'll show you what we've got here. Got our demonstrator here. And all it is, like I said, is just a blower motor. I've taken that blower motor and I've hooked it up to a power source, in this case just a jump pack. And I've got a switch on here that allows me to drive the motor, allow the motor to coast, or go into braking. I've got a loop here where I can measure the output amperage. And then I have jacks here where I can put loads on it. So I can take and I can plug in electrical loads to generate a force. So we're going to go through, we're going to look at that lab sheet, we're going to run the vehicle. So I turn it on, we got to see it driving. If I throw this thing into coast, that motor is just freewheeling to a stop. I put this weighted disc on there just to give it a little bit of inertia, otherwise the motor would stop almost immediately on its own. So again, got the battery applied to it, motor spins, throw it into coast, and it just slows down as it normally would with just basic resistance. Now here, where I go from drive to brake, we really don't see any difference because there's no load on that motor. As soon as I throw a load on that motor, we're going to see a difference. So what I'm going to do is I'm going to take a load. In this case, I'm just going to put a light bulb in there. I'm going to take that light bulb and I'm going to plug it in to my first load, spinning the motor. Nothing happens with the light bulb. When I throw this thing into brake, we see that light bulb lights up, and if you're paying close attention, you can see that it took a little bit longer for that motor to stop. So if I put it in the coast, right, it took a little while for it to stop. Get it up to speed, throw it into braking, slow it down faster. So we're actually applying braking. Now I can go ahead and I can add another load. So I'm going to put another light bulb in here. Throw it in the brake, stops even faster. Put another load on there. Throw it in the brake, stops pretty darn fast. So by adding these electrical loads, we can slow that vehicle down faster. Okay. Now, to get a more direct measurement on this, I've set up a lab scope. And we're going to take a look at the lab scope, and we're going to measure the voltage being generated. We're also going to measure the amperage being generated. And we're going to be able to actually measure the amount of time it takes to slow this thing down. So I'll get this set up and we'll take a look at that. Alright, so I've got this set up with the lab scope. I've got the amp probe hooked up so we can read any amperage that's coming through it. I've also got a voltmeter hooked up to two of the jacks so we can read the voltage that's being generated by spinning this wheel. If you can see, I'll zoom in on this a little bit so we can see what's happening here just a little bit. Our traces are basically flatlined down there at the bottom. The green line is our voltage, the yellow line is our amperage, and if I just take and turn this wheel, you can see even on that screen that we got a little bit of changes in input. Okay, if I turn it the opposite way, we see it goes the opposite direction. If I go back and forth, look at that, I got an AC signal. Alright, so I can generate voltage just by spinning this magnet inside this wheel. So what I'm going to do, as I showed earlier in the video, I'm going to take and I'm going to turn this thing on, and then I'm going to throw it into braking. When I throw it into braking, we can see the spikes in our voltage and amperage. So looking at this, I can see where it was spinning, and then when I hit the brakes, boom, I got the spike in voltage and amperage. And if I trace it back down, I'll see right about here where it stops. That's where the motor stops spinning. So we came to a complete rest from that rotation. So what we're going to do is we're going to take a look at these. I'm going to get a better picture of the screen for you. I'm going to go through and I'm going to put one light bulb on. That's going to be our no load situation. Then I'm going to put a second light bulb in and a third light bulb, and we're going to record the information for each one of them. Then we're going to compare them so we can see that as we add more load, the wheel spins or comes to a stop quicker. All right. So let me get this zoomed in on the lab scope so you can get a decent picture of it. All right. Get that running. Now again, I've got one light bulb hooked up on here, which is going to be our no load situation on the lab sheet. There has to be some load. If I've got unplugged, I have no light bulb hooked up now, put it into drive, throw it into braking, we see voltage, but we don't see any amperage. All right, because we don't have a complete circuit here. So what I'm going to do is I'm going to go ahead, plug that one light bulb in, get it spinning, throw it into braking. All right, and we can see the pattern here. So looking at that pattern, we're going to take and we're going to measure this out. Now again, looking at the time, this is how long it took for that wheel to stop spinning. And if I look at it, I've got this set up in a 10-second frame, and we started that braking started to occur just before 5.5 seconds. And it came to a complete stop around 7 seconds. So we're looking at 1.5 seconds to stop it. That's with one light bulb. This is our quote-unquote no-load situation. I'm going to take and I'm going to put a second light bulb in there. Alright, so I got a picture of that so I can include that with the lab sheet. Now I got two light bulbs hooked up, same process. Got it spinning. I'm going to throw it into braking, and then freeze it. Now if I look at this again, I can see my voltage, I can see my amperage. Looking at my time, hit it again at about 5.5. Alright. This time it was a little bit quicker to stop. Okay, so this one a little bit more than 5.5 is where we started it, and just before 7. So we're less than 1.5 seconds. All right. Now I'm going to add the third light bulb, and we'll go through the same process. So now we have 3 loads on this. We're under a heavy load situation. Clear my screen. Throw it into braking. All right. And that one is obviously slowing down faster. So here it took just a little bit over a second for it to come to a complete stop. So we can see the difference. And we're just throwing in light loads here. These are not heavy loads. We're just talking about simple light bulbs here. Not a big deal. When you start throwing in a load, like trying to stop a car, it's going to make a huge difference in the way the pattern reacts. So again, we're just converting that kinetic energy into electrical energy. The change in the energy forms is what stops the vehicle for us. Instead of going from kinetic to heat energy in a standard friction brakes, we're going from kinetic to electrical energy. It's going to slow the vehicle down for us.